In our last few videos, we saw from type 1 to type 6. In this video, we will be seeing type 7, which is on limits. So let's get started. Before starting, please pause this video and have a look at these general properties of definite integrals. In our first problem, we have to prove that integration of sin x over sin x plus cos x dx is equal to pi by 4, where the limit is from 0 to pi by 2. First, let us assume this part as I. We can do that. Next, one of the property of definite integrals is that if the limit is from 0 to pi by 2, then we can write pi by 2 minus x in the place of angles with the trigonometric functions. So we replaced all the x with pi by 2 minus x. In the next line, it is changed from sine to cos. How? Because we know if there are odd number of pi by 2, then sine is changed to cos, and similarly cos is changed to sine. And about the sine, have a look at this. From this diagram, you can see which trigonometric functions are positive in which quadrants. Since pi by 2 minus x is in the first quadrant and here all are positive, so sine was not changed. You can also remember this in this way: add sugar to coffee, where all the first letters denote the trigonometric functions: sine, tan, cos, and a means all. So this way sine was changed to cos and cos was changed to sine, and there is no alterations of sine, as in the first quadrant all trigonometric functions are positive. In the next line, I added I with I. We can do it this way because it's just the same way like we add or subtract or multiply different equations to find the variables in those equations. Similarly, we can also do this I plus I. If the first I value is sin x over sin x plus cos x, and secondly we used I equal to cos x over cos x plus sin x here. Then we added the two I, and why we did this? Because if we add the two i's, we will get the same thing in the denominator and numerator, which will be cancelled, so that way it will be reduced a lot. So in the next line we just added and we got sin x plus cos x over sin x plus cos x. Since we have the same thing in the numerator and denominator, so we got 1, and integration of 1 gives us x, right? So we wrote x. Next we wrote the limit, which is from 0 to pi by 2. Now how to put this limit? First we have to put the value of upper limit in all the places of x. Next we have to give a minus, then we have to put the lower limit, which is 0, here in all the place of x. So we did that and got pi by 2 minus 0, and value of which is pi by 2. We have a 2i in the left side, right? The 2 went in the right side, so we got pi by 4, and we had to prove the value of the given function is equal to pi by 4. So here it is, we have proved that. Solve number 2 and let me know the answer. The next problem is same as before. First we assumed the given thing as I, then we changed all the x to pi by 2 minus x, because like I said before, if the limit is from 0 to pi by 2, then we can exchange the angles with pi by 2 minus x. That's what we did. And like the previous way, we changed all the cos to sine, as there is odd number of pi by 2 or 90 degree, and all the cos to sine. And next, according to quadrant, the sign is this way. Next we added I with I, where firstly we used this value of I, next we used this value of I, and hence we got this cos x minus sin x over 1 plus sin x cos x plus sin x minus cos x over 1 plus sin x cos x. So after normal addition and simplification, we got 0 in the numerator, so ultimately the result is 0. And since we don't have any x, so we don't need to put the values of upper limit and lower limit. Thus we proved that left hand side equal to 0. In our next problem, we have to prove that integration of dx over 3 plus 5 cos x is equal to 1 over 4 log 3, where the limit is from 0 to pi by 2. Now let us first assume this part as our I. Now we can see that there is cos x. We don't have any formula for cos x, right? But we have a formula for cos 2x, which is equal to 1 minus tan square x over 1 plus tan square x. So to apply that formula, we brought an extra 2 here. So we wrote cos 2 into x by 2. Then we applied that formula here, so we got 1 minus tan square x by 2 over 1 plus tan square x by 2. Later we just added and simplified. Then in the next line we multiplied this 3 with the inside parts of the brackets and multiplied this 5 with the inside parts of the bracket. Later we took this 1 plus tan square x by 2 in the numerator in this line. Then in the next line we wrote 1 plus tan square x by 2 as sec square x by 2, and then we just multiplied this 3 and 5, so we got 3 plus 3 tan square and the rest is this. In the next line we just simplified, added this 5 with 3 and this 3 tan square with minus 5 tan square, so we got this. So now we can take common from this denominator, right? So in the next line we took common, so we have now 4 minus tan square x by 2, and we took this 2 of the denominator to the numerator, so we got this. Now we can see that there is sec square x by 2 and also tan square x by 2, and from our previous videos we have learned how to take some part as z, right? Since the differentiation of tan x by 2 is sec square x by 2, which is also present in this part, so we can assume tan x by 2 equals z. If you don't understand, just go through my previous videos, there I have discussed about assuming z. Now if we differentiate, we get 1 by 2 sec square x by 2, and in the right side we have dz by dx, and the dx was taken to the left side. Now we have changed everything in terms of z except for the limit. Since we have changed everything in terms of z, we also need to change the limit, right? For changing the limit, what we need to do is, first we will put the value of upper limit in the part where we assumed, that is tan x by 2. So we will put pi by 2 in place of x in tan x by 2, so we got 0. So the corresponding value for pi by 2 is 1, because tan pi by 2 over 2 is tan pi by 4, which is equal to 1. Now in the same thing, tan x by 2, if we put 0 in place of x, we will get tan 0, which is equal to 0, right? So for the limit 0, the corresponding value is also 0. So our new limit is 0, the lower limit, and 1, the upper limit. So we wrote the limit this way, 0 to 1. Now we will write this part in terms of z. So we did this. The upper part gives us dz from this line, and the lower part is 4 minus tan square x by 2, and tan x by 2 is z, right? So the lower part gives us 4 minus z square. This is what written, and 4 can be written as 2 square. Now we can see that we can apply this formula. Integration of dx over s square minus x square is equal to 1 over 2a log a plus x in over a minus x. So we just applied that formula here. In the next line we just multiplied this 2 with 2 and got 4, and in the next line we just put the value of upper and lower limits. In place of z, first we put 1, then we gave a minus, then in place of z we put 0. So at last we got 1 over 4 log 3 minus 0, which gives us 1 over 4 log 3, and this is what we had to prove, right? So we got integration of this thing is equal to 1 over 4 log 3. So that's the end of my today's video. Thank you.